In this video, I want to talk about calculating the expected value of a random variable distribution. I want to begin that by looking at how we understand the average or the mean. What we've always understood the mean to be is that you add up the numbers in a data set and divide by the number of numbers you've added up. Okay? I want to think about that a little bit differently. I want to think about it in that you could split the numerator, 2/7 plus 3/7, and so on, to look like this. And then I want to take it a step further and take the 1/7 out, so it looks like this. Okay? Now, why I wanted to do that is I wanted to show that we can adjust the likelihood of a score or of something by using how often it occurs. So in this case, where let's say this was 7 quiz scores. Okay, we've given the quiz to 7 people, and these are their scores. If we wanted to calculate the average, we'd add them up, divide by 7. But this could also, if you're shuffling the papers, and what's the probability you pull out the quiz with a 4 on it? It's 1 in 7. Okay, so we can really weight the scores here and say, well, 3 occurred 1/7 of the time. 6 occurred 1/7 of the time. And why this is a key is because we can then change likelihoods by changing this number. We can assume this is a probability of likelihood because in this case 4 occurred 1/7 of the times. Okay, so instead of always having to have the same weight, we can change that, and we could say that we have a new way of calculating the mean. So this new way of calculating the mean is we do the probability multiplied by the outcome, or maybe a better way to think about it, the outcome multiplied by the probability of it occurring. So 2 occurred 1/7 of the time, 3 1/7, and so on. But the beauty of this method of thinking about the mean is we can change the likelihoods. Maybe it's more likely that someone got a 2, more likely that they got a 7, less likely that they got an 8. We can adjust those likelihood numbers. And I'll show you an example of that on the next slide. The one other thing I wanted to say about expected value is this is a very similar, we call this the expected value. It's a very similar calculation to the mean, and it's used in very similar ways to the mean. And I want to point out that when we maybe have a test or something and we want to find the average, we add up all the scores, we divide by how many people took it. Let's say we say, well, out of a 30-point test, the average was 23.32. No student got 23.32 in all likelihood. I don't know any teachers that correct down to the hundredths place. But we don't really question that. That's the average. The same thing is true for the expected value. We might get an outcome that's not a possible outcome. Nobody might actually get that expected outcome. It's still the expectation. Okay? So that doesn't change. There's no rounding up to a different amount. When the mean is 23.32, we don't say, well, it's 24 or it's 23. It's not. The mean is the mean, and the expected value is the expected value. So just be aware of that, because sometimes that's a tricky thing to think about. Okay, let's do an example. All right, the lottery, or as I call it, a tax on people who are bad at math. So this is a game from the Minnesota State Lottery. I put the website there if you'd like to check out exactly what the game is. It's called Quick Sixes. And what you see here is amounts of winnings and kind of odds or probabilities here of how that's wins. So I'm going to define a random variable x as the amount won. Okay. So if I was going to make a probability distribution of this, I'd have my random variable x, and then I have the probability of x. So the first x is $1. The probability is 1/8. The next variable is 2, and the value is 1 divided by 13.33. I'm sorry, I'm not leaving myself enough room. 3 would be 1 in 40. Okay, so to calculate the expected value, we would take the probability multiplied by the random variable plus the probability multiplied by the random variable, and so on. And yeah, this is a long calculation for this game. We would have to calculate all of these. Okay, I have done that. I would urge you to maybe pause the video and try just to make sure you're getting everything correct, that it's just, the probability times the random variable, probability. It's the sum of all those. And the answer to this is 0.63, which means this is a dollar ticket. You expect to win 63 cents. So this is what we would say is an unfair game, because you're expected to win less than what you paid to play. And I don't think that that's earth-shattering for the lottery. I don't think anyone expects that the lottery is in business to help people make money. But sometimes it surprises people how much. Because, of course, if you think of a dollar ticket, the Minnesota State Lottery is making or expects to make 37 cents on each ticket. Now, this, I think, brings another point, which is when people look at this, they say, well, 63 cents is not an outcome, and that's expected. We talked about that already. But also, you notice they've never put 0 in here. And that doesn't affect our calculation because, of course, the probability of 0 times the random variable 0 is 0. But if you added all of these probabilities together and then did 1 minus that to get the complement, I'll just fill that piece in for you. The probability of 0 is 0.75. Okay, so you have a probability, 3/4 probability of winning nothing on each ticket. And that's why the probability is, or the expected value is less. Now, there's lots of math you can do with the expected value that works the same as the mean, where you say, well, if I bought 100 tickets, how much do I expect to win? $63. If you bought 1,000 tickets, how much do I expect to win? $630. Okay, so there's all kinds of math you can do with this. That, as I said, works the same way as the mean does. The big thing to get out of this is that the expected value is the sum of the probability times its random variable.